don't know me, I'm Ian Beckham. I've been with Intel way too long. In fact, my claim to fame, I guess, when I started was we were doing video conferencing over PSTN lines, right? So dial-up. Some people I'm looking at the ages of some people here and they're going, you had dial-up? I thought the internet was just, you know, always on, and I'm used to mega gigabit speeds. Yeah, so we were doing dial-up, and then we had the first Pentium 200 megahertz in the lab, which we dropped. It was the only one in Europe, so I managed to get a hairdryer and bend the pins back so we could actually slot it in. So that's kind of where I started, and then done a whole variety of roles at Intel, and you know, I still really enjoy it. That's, I guess, why I'm here. What we're going to talk on a little bit, and to be fair, Dave's going to be doing most of the presentation, was AI, right? And where everybody goes AI, hype, right? You know, you go and talk to any of the customers. I probably should explain what I do, shouldn't I? So kind of two roles. There's like looking after all the tech people in the UK. And then we also, I say sell, we don't sell anything directly to end customers. But I have a team that looks after health and life sciences and finance and some of the other end customers. And we actually go and talk to end customers to understand what their problems are, what their pain points are, and talk around how Intel Solutions can help them. And Dave's part of the team that actually does, so he's a finance guy, right? I know he doesn't look like it. He can tell you about what he did in Australia, right? But he's a software developer at heart, right? I'm on the dark side, right? So he calls on end customers and we help them to solve some of their key problems. What I wanted to do was start high level. What problems are we looking to solve on AI? Because it means so much to so many different people. Are people programmers here, or people, I kind of reckon, are there some students in the audience as well? People doing masters and bachelors and stuff? Okay, so we're going to hit some, Dave's going to teach you how to, I mean, hopefully you know Python and stuff, right? So we will go a little bit more technical and have a look at it, but even I can follow it, so hopefully it should be good. But we'll start high level. So, part of my team covers health and life sciences, I already said. That's okay. Don't worry about it. I was going to say, actually, we got some prizes. That's not a prize, that's something to show. And I don't know what we'll do. Maybe these ones, what I normally do is I do prizes for questions, okay? Right? So it gets it a little bit more interactive than us, you know, droning on down, you know, a load of PowerPoint slides. Now, what's this one? This is a wireless charging pad, isn't it?
I believe it is.
We think that's a wireless charging pad. This is a coffee cup, you know. Yeah. Speaking to the mic, sorry. But this is a NUC. Anybody know what a NUC is? Next unit of computing. So that's actually a little PC in there. Okay, so we've got a really super prize on that one, I actually think. And then we've got some nice water bottles as well, and some pens and usual stuff. So, questions, prizes, okay? So this is what we do. Two examples here. This one is AI solutions for personalized radiotherapy, looking at detection of tumors, right? So when it comes to medicine, you're looking at personal care. You're looking for, when you're doing cancer stuff, the actual genome makeup of people, right? And then personalized medicine. So that's what that one's about. This one over here is NG, nasogastro tubes. So these are the tubes that when you're in hospital, they feed you and stuff like that. Super important you get the tube in the right place, because if you don't, it can be fatal. So now we do AI. This is fairly obvious stuff, I think, right? This is AI on the image. Is the tube in the right place? Yes, 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 yes. That's how we did it. We trained the model. Dave may, are you walking through? Well, we got some demos on face detection and stuff like that, right? We do. But we can do that. We'll do that afterwards, shall we? But it's, so you train your AI model. This is an apple, this is an apple, this is an apple, or this is a car, this is a car, this is a car, this is the make of Nissan car, etc. So that's what we've done here. We've trained the model to look for where the NG tube is correctly placed. This one, and this one's an interesting one, which is, it's around this pill cam here. So this pill cam, I won't show you a used one, but it's the size of a pill that you swallow, and it has cameras. So it has a camera front and a camera back, and it goes through your intestinal tract and looks for, I don't know, stuff down there, and horrible things, and probably cancer and stuff like that. It's all about cancer, sadly. And here's what you can see. You can see the images, and then what we do is we do AI on those images to look at, is it cancerous, not cancerous, is it good, etc. The tenuous link from that here, and normally I bring my drone along. The drone has AI because I get it to land on my hand. We've told it how to detect the hand. That same chip is in this, which is a neural compute stick. Okay, so this is AI on a stick, right? It's about 80 quid. Has TensorFlow, has all the frameworks that you can download. We could have probably worked on a demo where we plug it in, but it does VPU. So imagine putting that into here, right? Obviously, I have to get rid of some of the packaging, so that when you swallow it, then you could do inference more on a real-time basis, because at the moment you have to wait for it to go through the system. Okay. This is some of the stuff that we're working to try and solve real problems in the and look at manufacturing. We actually wrote some code. It probably took us, I don't know, 2 days before you go into the manufacturing area, detect that the person has a white safety helmet and a yellow coat. Fairly basic stuff, but they don't want people going in without the prerequisite safety stuff. So we knocked that one up, and they're like, wow, we didn't realize you could do that quickly and that easy. That's almost a segue. I think I've got a couple of slides here. If you are interested in, we've written some of these things up, right, published on MediWales, so you can read a little bit more about it if you want to. And then there's some stuff around the video capsule stuff there. So high level, I mean, we could probably spend an hour on some of this stuff if you're interested in. But what I wanted to do is tee it up to now for Dave to go into a little bit more detail on what Intel is doing to make AI a little bit more easier to do, right? And he's got some fantastic examples, so I won't steal his thunder. So, by the way, prizes, questions. Okay, so over to Mr. Helly. Oh, you got that one, haven't you?
Okay. So thanks very much for that, Ian. My name's Dave Helliwell. I work in Ian's team. As you described, I am basically a consultant for all types of applications, whether it be hardware, software, or a combination of platform-type services into the financial service industry. This is my first time at the BCS, and it's certainly my first time in this building. I feel very privileged to be here, so thank you very much for having me. I am going to talk about today, I apologise for the fonts. There's a slight kind of anti-aliasing problem there, but hopefully it's readable for those that are paying attention. So my premise today is that AI is a complex domain, and as a result of that complexity, that people find it very difficult to get started actually doing anything. in order to solve the sorts of problems they think or they believe that it has an application to. So what I want to do today is hopefully reduce some of the initial obstacles to incorporating AI techniques into our projects. I'm going to have a quick look at what I think is the kind of AI domain. I have traditionally been, in fact, I think anyone that goes through a university system or does any kind of serious research into AI eventually turns around and says, well, everything that's said about AI makes me kind of recoil in horror. And as a result, I'm not going to use the word AI ever in my entire life, or the abbreviation AI. But eventually we get used to it, like bad punctuation and things like that. So I'm just going to use the term AI. I'm sorry for people if that's offensive. I'm going to try and define it, and then I'm going to try and look at some challenges that I believe are impediments to getting started, and then we'll go into tools for the beginner, and then a little bit of recommendations around what we might want to be doing and how we go and do further research. Okay, so let's start with the operating premise that there are lots of opportunities for better decision making and automated processes that we can apply AI techniques to. I'll define AI techniques a little bit later, but traditionally we understand that there might be anything from cost savings, service improvements, better product differentiation, sales generation, so on and so forth, that we can apply either in our home projects, in our workplaces, or as part of organisations, basically trying to do some good and make things better in the world. They also come with some substantial problems. So typically when I'm working with the people that I engage with in the financial service industry, and indeed pretty much anywhere else, the fact that it's such a complex domain is a substantial impediment to doing anything. My partner works in a non-for-profit organisation. They have volunteers that come in and physically look at pictures and document what those pictures, basically what the features are of those pictures. So if it's a street in Hammersmith with some sheep in the 1930s, they write that down and they catalogue it so researchers can come and look at that at some later date. This, to me, seems absolutely absurd in this day and age. Yet, because it's a complex domain, they're a non-for-profit organisation, the assumption is that, this is not for them, they could never do anything like this, it's very difficult to do. Hopefully, by the end of this talk, we can convince people that, yeah, absolutely, you can do this sort of stuff and it's really easy to get started. Another big problem with the complexity is that not only is it academically difficult to grasp, the skill sets of people is traditionally not so great in that people are difficult to find who already have experience and they can demystify some of this sort of thing. Experience is sometimes difficult to ascertain. You do an internet search for this sort of stuff and it become very daunting. And resources such as infrastructure and devices on which to run our testing environments and whatever we want to do can be quite scarce as well. On top of that, I think perhaps because of the complexity, there's a great amount of ambiguity in this space. Academics have their own specific definitions of AI, all the way through to marketing type folks who have a completely different interpretation of AI. And in fact, if there's an automated process somewhere, it's going to be branded as AI at some point. And this it extends across the general public as well. I was buying some coffee the other day. The girl that was serving me had a tattoo on her arm and it said singularity. And I asked her, I said, "Are you a disciple of Ray Kurzweil?" And she said, "Who's that?" And I thought, well, okay, that's fair enough. Even the things that we take for granted as people who have some familiarity in the domain are just not really, I guess, widely distributed amongst the general public. For those that are not familiar, Ray Kurzweil is, you don't hear much about him these days, but the last kind of 20 years or so, he defined an inflection point in kind of the history of humanity where essentially AI or machines become sentient and then are able to do everything in the world for us, and everything's a lovely place. Okay, so I'm going to loosely define AI to be advanced techniques for meaningful machine interpretation of sensory data. And this kind of plays into the fact that we see AI mentioned mostly around everything that we can see humans doing. And particularly, humans interpret sensory data really well, and then they can act on that sensory data. And this applies to classification techniques in such as machine learning, deep learning, with its implied artificial neural networks and so on. And these techniques, they provide information about state. And state is really important because if we're producing agents that we wish to act on the world, they need to have a belief about their current environment, and they need to have a set of plans in order to actuate or deliver some change into their environment. And a belief state about the world is fundamental to this. So we use these techniques, not necessarily as an end in itself, although it may be. Document classification might just end up as document classification. We just classify the document, gets filed somewhere, and no one ever looks at it. But we might also say, all right, we've got an autonomous vehicle. It needs to know whether it's a mailbox in front of it or whether it's a woman pushing a pram. And these are very important states of the world, and we need to then use them as inputs into whatever we're doing. Now, as I said before, executing AI-based projects is not trivial. There are a number of issues that tend to get involved. Issues stem from the very beginning of a particular project. We define, someone gets an inkling that we can apply some sort of AI technique to a problem that we have. We've got a process that we think we can automate, or we've got some new idea for some new wonderful widget or something like that that we can produce with some AI technique, and we can go on and do this. Now, this perhaps might be true, but often proves to be misconceived. Over and over again, I have people in kind of my consulting career say to me, Dave, well, we want to do an AI project that relates to this and this and this. And what becomes really quickly apparent is that because they're not familiar with the tools that are generally in place or generally available to work on these types of domains, they A, have a problem with the classification of their problem, or an issue with the classification of their problem, and B, an issue with how to solve it. So what you tend to get is a mismatch. And what I found over and over again is educating people about what you can do with types of AI processes, they tend to start redefining their problems really quickly. And you say, oh, well, the process as we previously understood it, oh, actually, when we start to think about it from an AI perspective, we look at the process in a completely different way. And not only do we not want to do the thing we did before, we want to kind of we change it, and we can make a much better solution from what we might have conceived earlier on. So typically, there's a lot of integration of external consultants in this space, and what we see is organizations turn around and say, well, we'll get some consultants in. Because they don't have a good idea of what they want to do in the first place, they get some consultants in, and the consultants steer them into a solution that is probably a bad fit for what they want to do at the end of the day. So it's really important, I think, that anyone that has an idea or thinks they might be interested in pursuing solutions that have some sort of AI component in them, understand a little bit about the tools and the way we solve the problems in this space, because it really informs the problem definition and the way you apply AI techniques to the problem. Again, practical issues are, of course, a technical domain. I kind of talked a little bit about that before. The elephant in the room with any AI discussion is the data pipeline. What I mean by data pipeline is how you get access to data, how you get access to your information in order to build your AI processes. I am almost like a broken record with this, and say if you're in a meeting and someone pulls up, well, we've got to automate our data pipeline and we've got to streamline our ingestion process or something like that, run away and start doing your own thing immediately, because that is going to go nowhere. You're going to be stuck and sitting there forever, particularly in financial services. It might be a lot easier in kind of smaller organizations, but in financial services, trying to refactor your data pipeline, you probably go through 5 generations of CEOs and IT kind of head honchos before you get anywhere with this sort of stuff. It just takes forever. And so if that starts happening, you're going to be in a real rut. So starting to talk about data pipeline and access can be a problem. My recommendation is always get what you can and run away. That is literally as simple as it can. You can get your data, you start something small. As soon as you have some traction, if you can make really small kind of changes to really anything in your environment, people do tend to sit up and look and take notice. So get as much data as you can, do it as fast as you can, and then just run away from the data pipeline issues, because it's just going to bog you down. Regulation is a massive problem well, it's not a problem. It's an obstacle to implementing some processes in the AI, and that can be a very good thing. And resources is another big issue, trying to actually get people and time and infrastructure in order to run these types of things. And then there are political, social issues, there's ethical issues, and again, regulation comes into another bucket here, and team objectives as well. I am not the biggest fan of teamwork in the world. Sometimes it works really well. It's generally thought of the best thing anyone can ever do in their career. I don't really agree with that. Sometimes teamwork works really well. I find in AI processes, unless you have picked the people that you want to work with, it can be a real problem, because other people have totally different sets of objectives. They want to learn something, or they want to do something that's new and wonderful. Have they different ideas, or their next job that they're eyeing off at the moment has such and such a title, and therefore they want to go in that particular direction. So that can be a real issue that you need to be really on top of. And organising your teams and structure is probably a way to solve that. I don't have any kind of silver bullets for that, unfortunately. So as I mentioned before, we tend to frame our opportunity. So this is a kind of high-level overview. It's not really to scale, but it highlights some of the things that it's basically a software engineering model, right? And if you kind of put a little waterfall here or something like that, you've got a waterfall model basically for software engineering. But what I wanted to highlight here is that, okay, framing the opportunity can be quite difficult. Building a hypothesis about can be quite difficult. Data preparation, again, a bulk of the work that we can do, and in fact, a bulk of the work we can really automate quickly without having too many skills in this space, simply by using the tools I'll go into in a minute, can be quite easy actually. And if you've come from a programming background and just a kind of reflection on how many people would say that they bash out a bit of code now and then. Okay, fair enough. So if you're familiar with some of these, particularly Python, Perl, Awk, scripting languages in general that are really good for data preparation, that you can use some of the tools, particularly with Python, to get things done really quickly. But the bulk of the stuff that I'm going to talk about today kind of comes in this kind of cycle here. We'll talk about data prep. We'll talk about how to integrate some models pretty much without even knowing we're integrating models. It's kind of that easy. And then we'll talk about how to deploy, once you've got a model that does some, takes an input, does some fancy stuff on it, and then says, all right, you've got a cat or a carrot or whatever it is at the end. Then how do you integrate those into your application? I'll show you a pretty easy way that we can get that sort of stuff done as well. So the bulk of what we're going to be talking about is in this 4, 5, 6 region here. Any questions from the room so far? I'll take that opportunity to have a bit of water. Okay, so bit of jargon here. And basically what I want to demonstrate here is that AI techniques such as machine learning, of which deep learning is a subsection, typically have a kind of 2-stage life cycle. Now, the actual implementation, i.e. the training of these models, is kind of out of scope because that is a complex topic. It's out of scope for what I'm going to talk about today. I'm going to talk about how we actually roll our sleeves up and do something that gets us the result rather than all the stuff that we do to prepare for that sort of thing. But effectively, we've got a 2-stage process. So one of those is going to be the training phase, of which is incredibly compute intensive, and it gets us a model effectively into which we can feed data in, whether that be text data, whether that be image data, or whether that be audio files or whatever, and then produces a result such that we have a confidence level to say the data that we get out as a result of feeding something in classifies that particular input to such that we have, if we're going to act on the state or the belief set that we get out of this inferencing or the output of our model, which we call inferencing, is good enough for us to say, okay, we can act, or we can inform our agent to act, and therefore we can start to make some changes to our world and environment. Another thing I wanted to comment on this slide is that typically in the deep learning space, large data sets for training are an absolute must. Now, these large data sets also imply considerable work in the data prep stage. So it's kind of another reason why I'm not really going to talk about that too much at this stage. But this sort of graph is a really kind of ready indicator for what you might want to be applying deep neural networks to in terms of the space of your input domain. Whereas, again, my partner, as I said, works in a small non-for-profit. There's no way she's going to be looking at things that imply deep, or at least going into training for deep learning processes. So she doesn't have to worry about all this sort of stuff. She just wants to use a model at the end of the day that's going to get her an output. And there's lots of pre-trained models that we can use. And that's what we're going to be looking at right now.
Excuse me.
Yes?
Slide. What are model weights?
Model weights? Yeah. Sorry, this is the back button. Oh, there we go. There's a delay. Okay, so the model weights are effectively, what's a good way of summarizing? Attributes that we put on a feature of a model or a particular process during part of the processing. So in one of these models here, effectively we have a machine learning model at each one of these stages. And these machine learning models are very specialized. So for an image processing, for example, our first model here might be good at detecting lines that are oriented in a certain direction or clusters of pixels that we think are at the beginning of a certain attribute. So if you think about eye detection and face recognition, you might have, we've got a certain cluster of pixels that forms a line of approximate shape, and it's got a sort of circular object next to it with some dark bits around it. It then gets placed to the next model that says, oh, is there another one next to that? And then is there a line near it that's kind of like a nose? And you can, for each one of these steps in the process, you get to build, if your object is face detection, for example, you can get to build up at each layer a more and more abstract scenario in that we put all these pixels together once they've been kind of torn apart by the machine and read in, and then we put them back together again and we add meaning to them at each level. And the features that we are looking for, we can add weights to each one of these at any particular time. So these are part of the tuning process. So when we get a bad result, particularly in machine learning, we can turn around and say, oh, well, we think that we were looking for too many pixels, or the cluster was too long, we want to reduce that, or something like that. Hopefully that answers your question. So I'm not going to dwell on this particular part for very long at all, but actually that raises a good question. Is there a medium by which I can distribute this content at all? Is there a web page or notes? It'll be on the website. Okay. So basically, the bit I wanted to talk about here is that we will be using some of these models in the next, I don't know, maybe 45 minutes, and we'll walk through, particularly in the space of natural language processing. We will be using some CNN type models. We will be using some speech recognition models, particularly hidden Markov models. We will be using some speech to text models, and I think we will also be using some image processing models and classification models. So these are some of the ones. This is just a kind of mapping to what is kind of out there, what they're pretty good at. You can look at this and kind of just get a mental map, or you can just Google it because this information is pretty easy to find. Okay, so we'll start the practical session. Basically, what I want to do here is demonstrate that we can quickly build prototypes. From the building of these prototypes, we can get some sort of understanding, a little bit more about the domain. We can learn from the results, and then we can advance the way we reason about the domain and its application to the problems. Going back to the issues that I said that I typically see is that because our practitioners don't necessarily have even a moderate grasp of the sorts of applications that they can, or the sorts of techniques that they can apply, that kind of creates an impediment to their understanding of the problem and what they can do generally. I think that's probably true in everything in life. So that's what we're going to do. Then we're going to walk through some simple and practical examples, incorporating some of these techniques. And the first thing we're going to look at is basic tools, which is Python and its plugins. I am probably, I guess, in my computing career, a recent, convert to Python. Started off as a kind of kid in a Unix environment, dedicated to awk and sed and that sort of a thing. And then my first lecturer at university was Damien Conway, who was actually not Larry Wall, he's a disciple of Larry Wall, who is now the maintainer for most of the kind of major Perl code that you see. And so I was a big Perl kind of user at university, and then I thought, Python, it's a language for kids and all that sort of stuff. You don't really want to use that. But I really started to see a little bit more when I was working in HPC, and all the people that were coming to me at the university I was at the time who wanted to get stuff up and running were all guys in the mathematics department. They were all using Python. I thought, okay, this is really starting to kick off. And then when they started bringing in kind of alternatives to closed source software type projects, so alternatives to MATLAB and things like that, I paid more attention. And then I thought, all right, well, Python's a great thing. And I cannot recommend Python enough. If you're A, learning a programming language, or B, trying to implement AI tools, because it's like cheating. It really is. It's ridiculous. So basically, I'm going to introduce the term data science. Data science is another term I'm not that particularly comfortable with, but it's generally applied, and it means to do analytics processing with data using programming languages and sorting through data using tools and techniques that I'm going to be talking about. So it seems fairly applicable. So Python is really easy to read and learn. It has a built-in REPL, that's a read, evaluate, and print loop, which means basically I can just type Python into my console, and automatically Python spits out some information about what it's doing, and then I can start typing things, and I can do things like print hello world here, and it just spits out hello world. It automatically executes the command I'm running, and I can see what it does, which is a fantastic learning aid, which means you can just do anything in Python with relatively minor consequences and just see what it does. You can play with it. It's also self-documenting. You can see the first thing that it spits out is type help if you want to figure out what you're doing. I'm importing a couple of packages here, and I'm printing some stuff here just to see what it does. And then in my packages that I have import platform, for example, later on I type help platform, and I get a screen here that tells me, just like a man page in a Unix environment, everything that I need to know to run all the subroutines that are associated with that particular module, which is fantastic. I can learn on the fly. I don't need to distract myself or swap my attention to a book or something else. I can get most of it done really quickly. So it's a great learning environment. And there are plentiful, even if you want to just go out and do some reading on the train or something like that, there are plentiful resources and learning aids out there which are really, really useful. Particularly one of those, if you're, I guess, a novice to programming or Python in particular, this Google link here, Python's like the lingua franca at Google, unless they want to do any kind of high performance computing, in which case sometimes Python's not that great. And you might say, oh, but Dave, you're talking about AI and Python, that AI is sort of high performance. I'll get to that in a minute. So one of the reasons why I say it's cheating is it's just libraries for everything. And what I mean by that is it abstracts really well from all these complicated tasks that you might want to get done. And we'll go through this in a minute, but I can just import a module, and I can say, right, I'm going to go out and pull text from Wikipedia now, or interface with a device down the street, because there's a pre-built module for that, and there's literally libraries for everything. It's just incredible. Like I say, it's cheating. Math and AI and visualization libraries in particular, these ones, SciPy and NumPy, have been around, I don't know, since probably the early 2000s. They're very, very solid. They've been implemented for a long time. NLTK was a natural language toolkit, which we can do a whole lot of processing of data. We can also do some kind of minor machine learning tasks. Scikit-learn, another module that we can import. There's a whole bunch of subroutines and algorithms that we can implement AI practices with. Keras, there's a whole bunch out there. We're just going to look at a couple today. It's fast to deploy in that I can start learning and I can start getting stuff done really quick. But because it is so user-friendly, there's typically a trade-off between runtime performance, that is, how fast it performs under certain workloads, and the immense capabilities that it provides for you. So I'll just run through this again. So for those who are familiar with Python, sorry about this, it's going to be really tedious. But effectively what we're doing here, and this is the key thing for importing modules here. So we're starting up Python. The first thing we do with these chevrons here is import a module called platform. That's going to give us an ability to interact with the platform that we're running on. And then another type of import statement here is this one here. From OS, OS is a module, we're going to import uname, which is a function in or a subroutine in the OS module. And it's going to allow us to get information exactly as if we typed uname -a in our Linux terminal. i.e. it tells us about, it's the OS module, it does stuff, it interacts with the OS. And we're going to import it as uname. This just means we're using a different namespace, which means basically we're pulling in only a small part of this particular module in order to do what we want to get done. And it's just basically looking up our uname. I've only done this just so I can demonstrate how we can import stuff and how easy it is to use these types of modules that do really advanced stuff. In the same way that we just look at stuff on our platform, we can import these and start working with them. And then we can type help about them and figure out what's going on. Cool. Now I said, and it's shameless plug number one from Intel. So I said that in some scenarios, Python might not be the greatest thing for really, really compute-intensive tasks. Now, I mentioned that I'm not going to talk about actually training models, which is probably the most compute-intensive thing you can do in the AI space. But if you want to run inferencing on models, which is taking that model and then getting actual results from it, we're not talking about a massively compute-intensive task here. But we can improve the performance considerably of our Python environments. Basically, Python is built, as many programming languages are, to run on as a heterogeneous space as possible. We know that our computing environments typically aren't, or typically specialized to either x86 or ARM or something like that. And when we're running our Python environment, we want to run the best we can on that particular environment. On x86 platforms, Intel has a bunch of high-performance computing libraries that take the hardware to the maximum extent it can possibly run. And particularly when we talk about the scientific and AI applications that we'll be probably wanting to use, they're all built on what's called Intel's math kernel library, which takes advantage of everything that the Intel engineers know about the processor. So the people that write Python modules don't necessarily know about optimizing every little bit about the newest processor that's just come out. Intel kind of does. So it develops these libraries that you can then plug in, such as the Intel distribution for Python, and get the best performance. And then there's a whole bunch of code analyzers, such as vTune, that you can work if you're getting really advanced in these types of topics.
Hey David,
yeah.
The Intel distro is free, right? So that anybody can download that, right? And you can automatically get a performance bump. The vTune, I think you probably have to pay.
vTune is there is a free version out there. You just don't get support for it. Okay. Now, Ian makes a good point. Intel provide a massive amount of open source software into the computing space in general. We're the biggest contributor to the Linux kernel in the world, have been for the last 10 years or so. We provide all sorts of device drivers, libraries, and so on and so forth to optimize your computing tasks, whether HPC, AI, whatever it is you want to do, there will be an optimized version out there that we provide. Okay, so the next thing we're going to have a look at is text analysis. And this is, you'll see what I'm talking about cheating in a second. So text analysis is a really common use case based on natural language processing techniques. And typically, the main use case is like document summarization. When we can summarize a document, you can do all these sorts of things like analyze social media or something like that. Why you want to know what people on social media are saying, I have no idea. But people do want to do it. So you can use it for things like that, sentiment analysis, so on and so forth. You can use it for document classification, security types of documents in your environment. At Intel, we have a massive problem in that everyone that ever produced a document at Intel clicks every single field you could possibly attribute to that document. So when you go and search for it, with systems like this, and I've been kind of banging on about this at Intel for a while, you can actually just run a really simple piece of code over the top of it, and it will spit out the keywords for you. It'll summarize the document, and you've got AI in your hand, basically. Really easy to do. And it's actually implementing really sophisticated AI techniques. Some of the basic text summarization methods, basically you've got to prepare text generally in order to feed it through a model that will then classify your documents. And typically a model is a vector of some kind that effectively just counts words or counts n-grams, which are chains of words, or counts the context of words that relate back and forth toward each other throughout a document. So you get a vector and you feed it into your model, and your model says, these documents are very similar, or these sentences are very similar. The main content of this document is such and such, and therefore we're going to classify it as such. But we'll step through an example and we can have a look. So,
can I ask, can it do a taxonomy of the document, not just summarising it?
Yes, you can. So what we're going to look at is a module called GenSim. However, where is it? If I go back here, so scikit-learn. What else do I have? Keras and NLTK are excellent for that sort of thing. All these sorts of tools that will basically build the initial representation of the document, so that then you can do all sorts. So once you've got an initial representation, then you can then define your features across that document, and you can say, well, okay. Exactly. So let's go to the example. So the example is we're going to use GenSim, which is a module we just import. Our input will be a bunch of text. Our output will be a list of sentences representing a summary, and we'll also do some keywords. So what do? We import our module, we initialize our data, we get results, and then we think about our optimizations. Let's have a look. So hopefully people can see this okay. I don't use PowerPoint that much, so I don't know how to kind of embed code in it. If there's a nice way to do it, but this is the way I came up with, and I thought running something live was just fraught with danger. So anyway, what we've got here is we initialize, this is a script, by the way. So this is a text file that we start typing in. We initialize our Python environment. We import our modules. So from our GenSim module and from this particular subclass, we import something called summarize. Okay, and summarize is a function that's going to help us with our funnily enough, summarization, and similarly so for the keywords. And then we import a module called Wikipedia. And as I said, we need some text to work on in order to actually summarize something. Wikipedia is going to pull a document from Wikipedia, and the particular function that we use here is Wikipedia, get the summary of the Wikipedia page for Intel. Right, and the summary is the bit at the start of Wikipedia, under the URL that's got, maybe 2 paragraphs of text or something like that, and then all the kind of topics come in, history, scandalous behaviour, whatever. Nothing like that at Intel. But that's what we're going to do. So we're going to pull that in, and then we're going to do some, really simple. That's probably not even a good way to do it. Really simple manipulation, just to get rid of a couple of new lines that come in when we pull this data into our text file, which is this. So this becomes an object that holds the text, And then we're just going to print that data out. And what we get is this. Intel Corporation did something at some particular time, and, you know, all this sort of stuff. So it's got a fair bit of text there. I don't know, it's maybe 500 words, something like that. So we're going to summarize this text. So we imported our module before called gensim, and we saw there was a summarize function. And basically, that's what we're going to run. So we have that data, we printed it out, we looked at it, we kind of know what it is. We're just going to print out the summary now. So we're going to summarize the data, put it in this temporary container called summary, and then we're going to print that out. And this is what we get at the end. Now, I think that's pretty amazing. And this is actually a pretty accurate portrayal. So what this does, it uses an extractive technique. Basically, the algorithm it's using is very similar to Google's PageRank algorithm. And when you think PageRank, you might think it's got to do with actual ranking of pages if you search for something, and this is what comes up. That's not really what it works. PageRank is actually named after Larry Page. And what it does is counts the number of links that are common between documents. And this gensim algorithm basically says, all right, we've got a whole bunch of sentences with a number of words in common, and then makes inferences about that to say, these therefore must be important. And what it does, it gives you a ready-made method to actually extract summarized text. Now, there are apps. You can buy apps on your phone that do this sort of stuff. For executives who are too busy to read, Dean Koon's novel or something like that, you can get an immediate interpretation of the first 5 chapters in your hand on your phone. So this has immediate applications. It has immediate application for classifying documents, and it's actually pretty accurate. So if I go back here, there's maybe 15 sentences. I think it's pretty difficult to display this on this screen, but it's basically picked out a sentence from here, a sentence from here, and then another sentence from over here. And you can see that represented there. And it really is really good. If you were to summarize what Intel is from the Wikipedia page, that's pretty good. I'm pretty happy with that. And it's, like I said, it's cheating. It's like 12 lines of, less than 12 lines of code. And then a really cool thing, and this applies particularly to the word strings that are attached to documents in things like document management systems that I said are particularly overused where I work. You can then get a set of keywords with that keyword function that we imported as well. And we just print those words out, and this I've limited to the words equals 3, and you can see there's actually 5 words there. And what that's actually doing is building the first 5 words, I think plus 1 word for what we're actually summarizing, and then 4 words for the size of the array that's associated with that. Hello.
Presumably those are ranked on kind of context and the mix within it rather than just a number.
That's a very good question. And it's something that I don't actually know. So what I know is it's populated an array with keywords. Now, I would assume, I think in my haste, I thought, oh, actually, they look relevant enough to me, so I'm going to use them. But what you can then do, because you've got access to all this data, and this is like literally 12 lines of code, took me a minute to code. What you can then do is actually do further analysis on top of that. I don't like any of these words, or the next process would obviously be do some word stemming on this, right? Microprocessor, chip and chips. Let's just take chip and call that the only word that we want to have when anything like chips comes into mind. And then you can get more sophisticated and so forth. It's easier than 101, I think, whatever this is. But it's really effective. So if I wanted to do some document classification, if I wanted to do some sentiment analysis and keywords on, I don't know, a Twitter stream or whatever, people do it. Really easy way to get some results really quickly. Learn about, okay, then I can apply this. Does it actually work? No, it doesn't. And then go back to the drawing board. Then there are techniques on top of this that you can actually tune this quite a bit. So this keywords function here takes a whole bunch of arguments that you can say, all right, well, I only want to work with a certain percentage of words from the document, so on and so forth. So gensim, I think, supports a couple of languages, but generally there will be. So this is a problem everywhere in the industry at the moment. Some applications will work with multi-language, and multi-language support is a big domain of development in the area at the moment. But at the moment, I can't say whether this just supports English or not. I'm just saying that this is something you can do really easily. There's probably 20 models that are similar to this right now that you can use with just as easily in order to get something on it, and they're literally a Google search away. So I'm just trying to demonstrate that this is not hard, but you've identified a problem. One of the partners we work with is using a really advanced technique for text to speech, or speech to text rather, and one of the things that hits them every time they talk to a customer is, oh, we've got a branch in Zurich or something like that. Does your model only do English? Unfortunately, it does. In this case, I think there are probably a couple of languages supported. There are, there's constant development in this space. So if you need something else supported, there's probably something implemented in that language. In fact, there's probably a sub-function of this called detect language or something like that that you can run and then switch to another model if you need to. It's literally that simple.
The second question.
So these models are already trained. So one of the, I guess one of the problems that people doing sophisticated analysis. So Ian showed a bunch of health and image classification models when he was talking before, and we're talking about detecting cancers and all this sort of stuff like that. Models for these types of environments change relatively infrequently. And what I mean by infrequently is not in kind of spans of less than a week, right? Whereas there are some models, particularly dynamic models, that will change within minutes or so forth, that are permanently being updated. So when we're talking about models that have already been pre-trained, the actual frequency that these are being updated with would be in the cases that I'm demonstrating now, probably in the order of months. So these are software packages that get updated recently. I'm going to show another one in a minute that's updated pretty much every day.
Okay, so just to clarify, if there were new words that came into existence and the model had not been trained with that,
yep,
we'd have to wait until the next cycle so it could recognize.
That is a drawback. But I would suggest that if you're at the stage where you're advanced enough to be sensitive to that, then you're probably at the stage where you're in a position to actually train your own models, because the models that are doing this are basically generally freely available, and you just need to do the training. And the training part is the compute-intensive part that is a little bit more technical.
Can you preload it with keywords?
Can you preload it with?
If you're interested in that document, you could say, these are kind of things I'm looking.
Yes, there are absolutely functions to do that. I'm just doing a summarization based on that. All the tools, all the modules that I guess talked about before that I haven't really shown. Basically, I think I talked about text of word and bag of word and text embeddings or word embeddings before. These are mechanisms by which you can specify basically a corpus of vocabulary that you're interested in, and then apply your models based on that and score and train effectively based on that. Yes.
So is there a concept of incremental training, or do you have to go back to the beginning with an entirely new training data set?
Yeah, good question. So one of the, I guess, advances over the last maybe 10 to 15 years has been this scenario where we introduce techniques. I mean, machine learning's been around for a long time. What we mean by learning is we input labeled data, and the model actually gradually learns about its incorrectness or correctness over time. And so there's a subtle nuance each time we run through the model that there is I guess a movement in a particular direction based on positive results at the end or negative results at the end. And then there's also, beyond that kind of fine-tuning that the model does itself, a human intervention of adjusting the weights and parameters that we talked about before. So kind of both, really. Now, that particular aspect, I don't want to get bogged down in because it is a little bit more technical. Sorry about that. So that is pretty much the end of the document summarization component. As I said, one of my objectives is to show you that this stuff is really easy to do. You can take applications and modules that are already out there, incorporate them into your environment, learn, reason a little bit. You can make lots of optimizations to this if you wanted to, and actually start solving some problems that you have. And I probably identified a couple that we've got at Intel right now. The next thing we're going to have a quick look at is speech to text. How am I going for time, by the way?
You're doing it.
Excellent, excellent. So probably half an hour after this? Yeah?
25 minutes.
Okay, 25 minutes. All right, see how we go. You gave me time. Okay, so we're going to do some speech to text. So speech to text pop up all the time. I often, encounter customers who are basically looking at, trying to do some sort of customer satisfaction or real-time monitoring of conversations via an operator on a telephone, that they want to then implement that, do some text analytics over, and send that back to the operator's console to steer a conversation in a particular direction, or dampen a customer's concerns, or even just record the document because they think it's going to be, everyone's rung up their utility provider and said, we're going to record this for training purposes, right? So hopefully this is the sort of thing that they're doing on these, and they're using that to improve their processes and to demonstrate or help their customers in some way. And we have applications for, as I said, recommender applications, record management, and we utilize a variety of techniques, which I won't go too much into, but what we're going to use is a hidden Markov model right now, and that is embedded into Google's Web Speech API, and this is the one that I mentioned was updated fairly frequently, and it is basically a really good resource that we can just test out, speech files and figure out how good, what sort of immediate impacts we can get by analysing these. So we're going to input an audio file containing some speech. We're just going to get a transcription of the file out. Pretty simple, but then we can do all sorts of tools on top of that. We can take our classifier and we can classify that speech, for example, or we can put it into other models that we can do, much more advanced techniques such as these. So let's have a look. Okay, so we start by instantiating an environment in a text file. We import the package or module called speech recognition. Python programmers are generally pretty lazy. If you've got to type something like this all the time, they typically import them and give it an alias, such as something a lot smaller. And so we're going to use SR in this instance that stands for speech recognizer. Then we're going to basically alias this particular subroutine of the SR component, the speech recognition, and the bit that's called the recognizer, the bit that actually does work, and we're going to call it rec, short for record. Then we load the file. I've got a file on this particular system called test1.wav, and then this is basically similar to like a file open command, basically, but it just does it appropriate to this and in a format and a way that is easily usable by the speech recognition system. We're going to load that into a temporary object called test. Then we're going to format the file. So this speech recognition module really likes its own kind of format. It's kind of an audio file format that's particular to this. So we're just going to process that into the right format. And we do that 2 lines of code. It's really easy. It's well documented. And then we're going to do the recognition. So basically, we take our text object, we load into that our recognizer that's run across this audio guy here, right? And then we print it out. So let's see if I can navigate. So what the file is Harvard University produces a whole bunch of text files about that, or audio files about that long, that are designed to test speech recognition systems. And if you were paying attention, you would notice that we didn't do a great job of getting everything 100%. And this is pretty common in this domain. You're not going to get 100% accuracy with anything with just the vanilla implementation. You've generally got to tune things, you've got to do a little bit of work, but you can start out really easily. And you notice that this exists. This word was a substitute for something else, that it just thinks it's that, it's not really that, but we've got some errors there. What I didn't do when I made these particular implementations is spit out the accuracy rate, which I'm kind of kicking myself for now. So you can get an estimate of how accurate our analysis of this file is. And what we can do is we can do a whole bunch of things, such as adjust for background noise. We can fine-tune for particular types of speech inflection. So for particularly here, the guy was talking about how tacos something or other was his favorite food. And it sounded kind of Spanish. So I think we've got some problems there with the interpretation. So what we get is a pretty good representation, but not perfect. And then we can kind of gradually get a little bit better at this over time by using either this model or different models. Now, I should say, this Google recognized, so I said we're using the Google Web Speech API. This will only do kind of small files. It's there for Google. It's put there by Google, so you can just basically do something really small, really simple, just to test how good their algorithm is. They have a really kind of enterprise-grade application that sits in the Google Cloud Services. You got to pay for it. It's like 16 cents, I don't know, a megabyte or something like that of translation. But this is much more sophisticated. This is about as basic as models get. You can also get some models that you can run on your local machine as well. So there's web APIs for this sort of thing. But there's a lot of work going on in this space at the moment. And you can get actually quite sophisticated with it. But as I said, you can get started, get some ideas about what you can and cannot do. You can do some further analytics on top of your text file and make some inroads into that, which I think is pretty cool.
Excuse me, can the models actually detect the different speakers as well, possibly?
Yeah, so I remember reading that there are quite a few different sets of functionalities that will classify a reader of the file effectively. Yes, so that capability is there. Now, the exact implementation, I'm not sure of it. But, as I said, everything I'm showing here is pretty well documented. If you want to search it up on the web, it's pretty easy to find. The next thing I'm going to go through, we're in the home stretch here, folks, is what's called OpenVino. OpenVino is a video analytics toolkit. It's basically been built by the Intel software engineering groups across a whole bunch of different teams and I guess vertical domains that Intel works with. And it's built to just enable video analytics to be really easy to deploy and develop, really easy to integrate into your application, and deliver quite a lot of features pretty much out of the box that you're really ever going to need. Well, probably, depending on what you're doing, I suppose. Certainly in the first year of deployment, you're not going to need it much more than this. Now, what it does provide is a bunch of libraries, a bunch of tools, and a bunch of integrated demonstrations that you can learn from and deploy. So, in fact, I might even run, if I have time, a demo out in the kind of social networking area of some face detection algorithms that do classification of faces, and then on top of that face classification, determine whether it's male or female. With a ponytail, I get female sometimes, but it also calls me 21. So that model needs a bit of training, but it's really easy to get started with, doing advanced things, sitting models on top of models on top of models, and then getting, I guess, more and more advanced with the sorts of things you do with a set of pixels that a machine reads in. And it's also designed for a variety of endpoints. So as Ian showed before, where's your Movidius unit, Ian?
Somebody's stolen it already.
Oh well. Basically, there are a bunch of endpoints. So what we want to do inference on video in particular. You typically find that people want to do analytics at the edge. And what I mean by at the edge is you've got a video camera, you're taking in this footage, but then you've got to send data across the network, data's large, and then you've got to do some analytics on it, and it takes a while before you can actually figure anything out. If you can do something at the edge and detect something really rapidly, then you can basically just send an alert of a very small 1 byte encoding of a message or something like that you can send, and bang, instantaneously you can get an action from your agent. So doing things at the edge is really important, and Intel enables these for things like this device that you can plug into security cameras, you can plug into routers at the edge or something like that, and actually do inferencing much, much more efficiently, or even enable it that you wouldn't have been able to do before. So again, what we're doing here, so I'm not going to talk about the training of models itself. Intel basically builds this toolkit where you import a trained model. It provides a whole bunch of trained models for you, by the way. ImageNet, all this sort of thing that are already there. That'll do all the classification for you that you're probably ever going to need, certainly in the kind of early stages of your life cycle until you're good enough to do your training yourself. You can import these trained models. It takes a variety of formats. You can optimize them, get an intermediate representation, and build them into an application that you can program in either C++ or Python in order to do your inference on a whole bunch of devices at the edge here. As I said, these could either be generic CPU, GPUs of various descriptions, FPGA, which is a field programmable gate array, which is a cluster of silicon that you can program and program again. People are familiar with things like EEPROM programming. It's kind of like that, but kind of for the modern era. Myriad, I guess, is another kind of small implementation that Intel builds, and a whole bunch of other types of devices that we can work with as well. So it becomes actually really easy to just pick up a trained model. You can convert it, say what platform you're going to run it on, how you're going to run it, what you want to do with it, and then build a bunch of model classifications over the top. So you can take one model that says, oh, I'm going to detect vehicles, for example. The next model you build into that says, I'm going to detect license plates within vehicles. The next model you build on top of that says, I'm going to extract the text from a license plate and put it into something. If you're building a security barrier, this is a really easy way to build an application really quickly that gets what you want to do done. And here's kind of an example. So the output that we can see here is a classified. We've identified a face. That is the first layer of our model here. We've then said, okay, we want to identify the age and gender of this particular face, and that is the next model here. And these are all pre-built models, and they're provided with this package, by the way. And this is free, open source. You can do whatever you want with it. And then we want to detect our head posture. And why you might want to do that, I'm not sure. We can see that this person is in an industrial environment, perhaps where there's, machines that might catch your hair or something like that. So you might want to detect the angle that their face is on with respect to a machine that you're working on or something like that. And then, as a result, send an alert if something goes hideously wrong. I don't know. But this is easy things that we can do. So gender, we've also got a model running in various labs around the world at the moment where we do a whole bunch of mood detection. So for folks in retail, walk-up kiosks where people they detect your mood, and as a result of your mood, they can make nice suggestions to you or something like that. That's crazy in retail. They're all over it. They want to do that at the moment. So there's all sorts of tools that you can actually really do sophisticated modeling and application and state analysis with. I won't go too much into this because I'm pretty much finished up, but I just wanted to note that basically what this toolkit consisted of, I said it was a bunch of tools that Intel had put together. So effectively, you've got the kind of pre-trained models and the model optimizer and all that sort of stuff. All the stuff that does the labeling, so all these models, they spit out a state, and we can get the state, we can read the state, and then we use these labeling tools, Open Computer Vision, which is stuff that OpenCV here, which is another Intel code base. It's been around for decades, pretty much industry standard for video and text input and annotation and things like that. So basically, we read that in. As a result of our analysis kind of in this part, we then start to annotate the text, and then we read that out. So we split it off into different segments based on what's in there. So we pull this out, then we get a fork, and we say, okay, we're going with this particular image, we're going to do some analysis on that, and it'll do the same thing. It'll fork off and do that image, and then we'll store the relevant information based on what OpenCV builds against attributes of the image, is what I wanted to say. And I think this is my last slide, and this is just a rundown of the sorts of models that you can get right out of the box for free, open source, go out and do work with. So we saw a whole bunch of models in Python. This kind of open Vino environment is a 100% Python compatible as well, so you can program with it in Python if you want to. But we've got age, gender analysis, face detection, head position. We saw all those sort of things. Human detection, eye level, and angle detection. people, bikes, you can kind of read that sort of stuff off the top there, but you can go out and it's got all the kind of object classifications in there from ResNet, ImageNet, all that kind of thing. You can go out and you can do inferencing and feed that information back into the applications that you're trying to build really, really, really easily. As I said, a lot of this is just, it feels like cheating. Whereas we've grown up to think that this is actually a really complex domain. All right, there's a lot of stuff that's hidden by the simplicity of the tools that are presented to us, but that should not be an impediment to the things that we want to get done. Yes? So when we're building our models, apart from we might want to get the models trained quickly so that we can deploy it into production, we don't really have an issue with performance degradations unless we're really worried about the utilization of our resources while we're building the models. When we're deploying these models into production for inference, is there a latency imposed by stacking models on top of each other? And yes, there is, because basically for each one, you're doing a different task. Now, what we can do is with applications like the vTune performance analyzer that I mentioned before, and from the native Python toolkits and so on and so forth, or even in C++, you can get the tools for this as well, is use our code metrics in order to optimize for bottlenecks and hotspots in our code. So if that becomes an issue, that we can address it, but certainly we can do this in very satisfactory time frames. Now, where I have, I mentioned retail is a big application for this. This is developed, the NHS slides that Ian showed before, deploying these sorts of, can I say that they're deploying these sorts of technologies, or is that confidential information? They're using these sorts of technologies right now. Retail, where they're trying to do instantaneous feedback analytics for what do you call the shops that don't have anybody in there? You know what I mean? Not that they don't have anybody in there, they don't have any shopkeepers in them is what I'm trying to say. So you pick up something off the shelf, it's already detected that you've got a mobile phone that's got a payment device in there. They're all over China at the moment. There's one in New York, Amazon's got one. So yeah, for that sort of thing, you probably want to do a bit of optimization over the top from the standard models that we deploy. And that's open to you. But for general purpose applications, the security one that I showed before, absolutely fine. Yes, these models basically come from, well, let's say 3 places. They're going to come from the major AI researchers of our time, the Googles, the Amazons, Intel, Microsoft, all those kind of guys, produce models that we incorporate because they're open source. Then they come from AI researchers who are the greatest at Kaggle, which is a website for kind of AI competition and learning and research. So we'll incorporate those where we see them as relevant, and Intel will build their own ones as well. So we would like to think that we avoid some sort of bias there, but I can't really comment on that. Yeah. What we're talking about here is models that have been trained with data. The data sets themselves that you feed in are you can feed whatever you want in. Now, having trained on a particular data set though, and as I said, the volume of the data that you put into the training cycle of these models is going to determine how accurate your models are in the end. So if you've got a diverse community such as London, for example, and you want to be any good at detecting faces, then you need a very diverse data set in order to train your model. And any model that's any good, that's worth its salt, will absolutely be taking that into account. And they're the models that we're importing into our environment. Cool. Well, that's pretty much it from myself and Ian, and thank you for having us.
Yeah, thank you.